My name is Albert Michelson, and I was a key contributor to the Michelson-Morley experiment. My experiment was after proving or disproving the presence of ether. Ether was thought to be the medium that light travels through and existed everywhere in the universe. This was similar to waves for water or air for sound. Due to the Earth's rapid movement through space, it was logical that because the ether is everywhere, we would be moving through the ether, so there would be something called an ether wind going around, and this ether wind would be measurable. If it was measurable, then it would mean that light would react different depending on where you are on the Earth and depending on how the Earth is moving through this ether. To test this, me and Edward Morley, we set up a semi-silvered mirror, and this allowed for some of the light to diffract through the mirror, and then some of the light to reflect off of it, causing them to go at 90-degree angles. They then were reflected back, and the diffraction pattern was observed, and if the ether did exist, then some of the light would be going through the ether parallel to it, and some of the light would be going perpendicular to it. If this was the case, then they would be going different ways through the medium, which would cause them to react differently. If they did react differently, then whenever they came back to the middle, they would cause a different diffraction pattern than what you would expect to see. So we were trying to prove or disprove if an ether even exists, and if it is, maybe we could find some more information about it as far as how much the Earth is moving through it, and different things like that, because we would know the basic information of how light reacts when it's going at 90 degrees different directions through the ether. I was currently in school at K School of Applied Science in Cleveland during this time, and I had actually tried it beforehand, but when I went into the Applied Science in Cleveland, I met a chemistry professor who worked, and he was in a neighboring school at Western Reserve College, and so we decided to get together. So in Cleveland, Ohio, is where we performed this experiment. So around this time, which was around 1887, Theodore Roosevelt's son was born, and also around this time, the Eiffel Tower first opened, which was in 1889, and this was actually the same year that Adolf Hitler was born. So as I mentioned earlier, Edward Morley, a professor at chemistry in neighboring college, was the other professor that was working with me in both the research and setting up the experiments. So my role in the project, well, I was the main person to do everything. So I did most of the research, I set up the experiment, I figured out how the experiment would work, I analyzed the data, I carried out the experiment, every part of it. I mean, it was really mine and this professor's project that we worked on together. So everything we did was just working together and trying to get it set up. So what impact did this have on the physics community? Well, whenever we did it, we saw that there was no difference in diffraction pattern. So if this is the case, because the light was moving at 90 degrees, then there can't be an ether. If it was, and Earth was moving through it, which we are moving through space, so it only makes sense that that was the case. So if it was going through it, then there would be no way that they would have the same diffraction pattern that they would otherwise, and they do. They had the exact same diffraction pattern. So this proved that there was no way that an ether could exist. And if it did, then we wouldn't be moving through it, so it really doesn't make sense. So how does this affect the physics community? Well, it's a pretty big deal whenever you're trying to figure out something like this. Whenever a big breakthrough in science comes through, it's always hard to convince people because people are always used to thinking about how things work on Earth. So telling somebody that light is able to travel without a medium really is hard for people to understand. And because of this, a lot of people didn't believe it for a long time. So a lot of people just said that it wasn't true. But as our technology got better and we got better lasers and things like that, we were able to get better and better and prove that it has to be the case. And so an ether cannot exist, so light must travel through no medium, or at least not a medium that causes a wind because the Earth is moving through it. So this was just a big deal for the physics community as a whole. It was actually thought to be one of the greatest null results for any physics experiment. So this, just moving forward, had a big impact on the physics community as a whole. What was the hardest part of my experiment? Well, I'd have to say the hardest part would be the physical strain and the concentration that it took to watch through a very small eyepiece while the experiment was occurring. So we spent all this time researching it, and we finally got how we want the apparatus to be set up. We got there, we got ready, and we're sitting there trying to concentrate, and it's taking a while. And we're really excited for the results. So That's the hardest part for me, was just really trying to concentrate and make sure we get the most accurate data possible. Thank you.